All right. So now we're gonna move on to network architecture in order to understand the architecture or the design of the internet. So this will be on backbone networks more specifically, which are part of the network architecture. Now, the network architecture at uh, at large is a layered and hierarchical design which enables global communication, data exchange, not only that, but also connectivity as well. So it encompasses things like physical infrastructure, encompasses protocols, as well as routing mechanisms in order to allow billions of devices to communicate efficiently. Now, a clear understanding of the internet architecture helps to explain how data moves across continents, um, as well as how different networks interconnect, right? So let's first understand or unpack the structure of the internet or the design of the internet, right? So we've said in the past, or I've said in the past, especially the first video, if you go back and watch it carefully, I've said that the internet is a network of networks. Is often described as the network of networks simply because it connects millions of private, public, academic, business, and government networks into a one massive global communication system, which is known as the internet. If you go back, you realize that I explained that, right? So the structure of the internet is basically a hierarchical and distributed network of network. That's the internet itself, right? So it consists of multiple layers. On top of that, the interconnected components like end user networks, which connect homes, connect businesses or offices, as well as mobile devices. The second component of the structure of the internet would be access networks. The access networks are the broadband networks I've referred to earlier on: DSL, cable, fiber, wireless, you name it. Many broadband networks. Go back and listen to um, and understand the underlying physical properties or the underlying physical design, right? So another component of the structure of the internet would be regional networks or ISPs, which would consist of second tier and third tier service providers, as well as the core networks or the backbone networks themselves, which are first tier ISPs or internet service providers, as well as international links as well. So, in order to understand how data moves across continents, data first of all travels from local devices. It travels through access networks, the ones that I've mentioned, like DSL, cable, fiber, as well as wireless, through into the regional ISPs or service providers, and then ultimately it gets to the internet backbone or the backbone networks in order to reach servers or data centers or other users anywhere else in the world, right? So that's how data travels usually. That's the structure of the internet. Now, since this is on backbone networks or the internet backbone or backbone networks at large or core networks, I'm going to narrow the focus mainly on backbone networks. So backbone networks, to understand them, the term backbone networks is often used interchangeably with core networks as well as the internet backbone. So the internet backbone is essentially a central and high capacity part of the internet that connects networks across multiple countries and continents, right? That's um, that's the internet backbone. So it forms the primary data highway for of the internet, and the several key features or characteristics which would help us, characterize backbone networks at large. So there are several of them. The first would be high capacity. Um, what do you call this? It's high capacity core networks or backbone networks, right? So, which would mean that backbone networks are built on high capacity backbone or core networks, right? So, backbone networks are designed to handle massive amounts of data or massive volumes of data or big data. That's how they're designed, right? So the traffic that is coming or is generated from millions of users or billions of users around the world is aggregated at the core routers, right? And backbone networks are essentially optimized for the character. Remember the characteristics that I referred to in the past three videos, right? They are optimized to have those characteristics like speed, reliability, as well as scalability, right? So that would be the first feature of backbone networks. This high capacity being built on high capacity core networks. The second would be being built on fiber optic links, which cover countries and continents, right? Remember, fiber optic cables, they they transmit light pulses that represent data, right? And they operate at extremely high speed to several terabits per second or TBPS. And one thing about fiber optic cables is, as you remember in the past, that they provide long distance connection or transmission with minimal signal loss. So we don't lose much signal using fiber cable if data is transmitted through fiber, because it doesn't matter the distance, could be thousands of kilometers across countries, but there isn't much signal degradation when it comes to fiber optic cable. So it supports long distance connection or long distance transmission of data. So backbone networks, the third or characteristic would be that data networks or no backbone networks rather, um, they use submarine cables. Remember submarine cables? Yeah, they back now. They're important. Everything I've said in the past is important and it's building up. So pay attention to everything I say. Right. So they use submarine cables. Remember, submarine cables are undersea fiber optic cables that carry much or over 95% of international internet traffic, right? So those submarine cables, they connect continents you across oceans like Atlantic Ocean, Pacific Ocean, Mediterranean Sea, Indian Ocean, you name it. Connect all continents worldwide, right? And if you remember the structure of submarine cables, I've said that they have protective layers, like steel armoring around, as well as water insulation, right? And they also use submarine cables or undersea fiber optic cables. They use laser transmitters as well as repeaters, or which are also known as optical amplifiers, in order to amplify the light pulses at every 50 or 100 kilometers distance, right? So the one particular example or some examples of submarine cable which I've not mentioned in the past would be the submarine cables uh, known as C, Me, We, which would stand for Southeast Asia, Middle East, as well as Western Europe. And there are submarine cables that connect, Europe and US. Those are MAREA or MAREA submarine cables, right? And they also are powered. The backbone networks, they're also powered by high-speed core routers. So that would be the fourth characteristic of these backbone networks, right? That would mean that the core routers, they direct traffic at the backbone or at the internet backbone, right? And these um, core routers, they operate at extremely high speed, which is usually like billions of packets per second, billions of packets per second. Those are extremely fast speed. Now, These routers, as I've mentioned in the past, they use routing protocols. I've mentioned the Border Gateway Protocol or the BGP protocol, which in order to determine the optimal path for multiple or across multiple networks in order to send the data packets across multiple networks. So that's the fourth characteristic. And the fifth one would be that they support very high bandwidth. And that high bandwidth would range from several gigabits per second to terabits per second, right? And ultimately, that means, backbone networks would support several things like IoT data flows, streaming services, as well as cloud computing and large scale video conferencing. So that's how powerful actually the backbone networks are, right? And if we go on to another characteristic that characterizes backbone network is actually um, one fact about backbone networks is that they are operated by tier one ISPs or tier one internet service providers, right? Those tier one ISPs, they own and operate most of the backbone infrastructure, right? And one thing about those ISPs is that they peer with each other without paying any fees, and that's usually referred to as settlement-free peering, right? They just exchange traffic with each other without making any payment, right? Because they are first tier ISPs, right? And the most common tier one ISPs would be AT&T. There would be CenturyLink, your Tata Communications, as well as NTT Communications. So those are all the characteristics or how we characterize backbone networks, right? Now, if we were to understand how they actually work, right, you have to understand three things. One is data aggregation, how it happens, as well as the routing process across the backbone, as well as the delivery to destination networks. So if you were to understand backbone networks, how they actually work, there's a process behind it. So the data comes from or is generated from local users and is transmitted or sent through access networks, your DSL, your cable, your fiber, your wireless, and so on, and sent to the regional ISP. The regional ISP or regional network um, would aggregate the traffic and then send it to the backbone, right? And then to the routing process at the backbone is there to direct packets across the backbone, right? And that simply means that um, the the routing protocols would have to determine the most optimal path to send the data packets across the backbone network. And then after that, the data packets would be delivered to the destination networks, or rather, the backbone networks actually route the data to destination ISPs or data centers as well. And then from there, the local access networks take over and deliver the data to end devices. So that's how backbone would the process of backbone network actually works, right? Now, the significance of these backbone networks, why they actually really matter, is highlighted by four things. And one of them is the high speed global connectivity. And what that simply means that backbone networks enable near instant communication worldwide or real time communication worldwide. That's how powerful backbone networks are. And the second thing is that they support the increasing scale of internet users, not only users but devices as well as digital application. So they are highly scalable. The third one would be the fact that uh, mm, backbone networks are highly reliable in that they use redundant systems. If you remember that redundant systems, I've said that they are useful in terms of when a network path fails, the data packets automatically need to be routed to a different path. So in this case, the backbone networks, they have the redundant routes or routes in order to ensure minimal delay uh, if it happens that a network path happens to fail, right? And they support as well, critical operations or critical services or online digital applications like cloud computer. I mentioned these things in the past, but now they should be familiar. Cloud computing, streaming, IoT, as well as government services. All of these critical services, any digital application actually is heavily reliant on the backbone infrastructure, right? Now, the, the backbone or the internet backbone or these backbone networks are essentially the essential or the central nervous system of global communication or global connectivity, right? And that would mean that they are built on, as I've said, they're built on fiber optic cables or fiber optic links, as well as high capacity core networks. And the second thing would be the fact that they use, submarine cables to connect continents. That's why they are a central nervous system of global connectivity, right? Because they use submarine cables, which I've said in the past that they carry over 95% of international traffic, right? They use these submarine cables or undersea fiber optic cables to connect continents, and they're operated by tier one ISPs. They're mainly owned by these tier one ISPs, as I've given examples like CenturyLink, Tata Communications, and others as well, right? And another thing about these is that they are powered by high-speed core routers, right? And that it is important to keep in mind that without the backbone networks that I've mentioned, that I've talked about, that essentially global communication or global internet connectivity, as well as most modern digital services would be seemingly impossible, right? So see you on the next one as I continue with the internet architecture. Namely, it would be covering regional networks, right, or regional ISPs. See you next time. Thank you.